Okay, now everybody knows what I just drew because everybody drew it correctly in the quiz. That's step one. Now, next time I ask you to draw it, that's 0 points. Okay? Until you got every bit, right? Make it perfect next time, okay? Including the red dot. You'll see why the red dot's important, and you will make it perfect, okay? Okay, there's a red dot in the middle of the lower boundary of the original square. Remember, construction lines are the lines I drew inside the square. Okay, and now we put points on this side. The first point is here, not here. A few people did put the first point at the origin and it ain't there. Specified point is at the left edge on the lowest construction line. This is a boundary line. This is a construction line. Make sure you correct that. Okay, very easy to correct. Here we're going to see. I'm going to fix my dad's support. Okay, then you move one right, one up, one right, one up, one right, one up, one right, one up, and you end up at the upper left-hand boundary, upper right-hand boundary. Okay, I don't know left from right half the time. And everybody got those points, except some people screw this one up. And if you screw this one up, it's 0 points on the quiz. Any flaws? Okay, so made that mistake, and a few people did. Take a list. Then you want to draw the curve through the points. It's a nice smooth curve, doesn't wiggle around. It's right on up. Okay. Make sense? Okay. Now, I want you to very quickly draw it again. By quick, and you can draw it in your notebook paper. I'm not going to take this one off. But do a quick sketch. Don't be meticulous. Do it within a minute. If it's not totally accurate, that's okay, because what we're going to do with it doesn't require total accuracy. Just be sure you get all the points where they belong. Now, it took some people maybe 3 or 4 times as long as others draw this, because some people just can't help being meticulous. Get over that. Be able to at least slop something down in 30 seconds, preferably. It's certainly no longer than a minute. Okay, practice. If you draw it 6 times, you'll be able to do it in 30 seconds. How long is it going to take you to draw it 6 times? Even if it takes you 3 minutes to draw the first one, the next one's going to be quicker, the next one's going to be quicker, the next one's going to be quicker. You'll be done in 10 or 12 minutes. Okay? And it's worth that 10 or 12 minutes because we're not going to wait more than that. And later on, maybe not more than 30 seconds. You want to be very familiar with these grids. Okay, they're very important. Now, we're going to do something with this grid. I want you down here to mark all the points that lie below the graph. Now, this is an example. Let's say you have a grid here. I'm not even going to draw the grid lines. And you have something like this. Okay. What points lie below these curves? Well, there's one here. There's one here. There's one here. There's one here. There's only many of them. It'll take you a while to do them all. But you can cheat and you can say, okay, go from here to here. And I just draw this. I put a little dot at this end, a little dot at this end to show that I've got a line segment from here to here and one from here to here. Okay, that makes sense? These line segments indicate the points that lie below the graph that I've got here. I don't know what that's a graph of. I could make something up. It'd be fairly close. But I want you to do the same thing for this, and it's a lot easier with this, isn't it? Let's see if you can do it. You might still be a little confused about what I said, but do your best. Okay, some people take a little while to do this, and so you probably didn't pick it up from verbal instructions, and that's okay. I never was very good at following verbal stuff myself, but maybe very good at it, and I just didn't say it right, so let's assume that. What all the points down here indicated that lie below points on this curve. Well, they start here. They end here. And there they are. Got them all. That makes sense? Okay. Now I want you to do over on the left side. Actually, let's do it on the line through the red dot. Because that puts you closer to some of the average. On this line, I want you to do the same thing with all the points that lie directly across from points on the graph. Okay. For example, you would take a point on the graph. Here's a point. Okay, well, you move over here, and now you got a point here, right? This point ought to be included, and so should an infinite number of other points above and below that, right? This point lies directly to the right or left of this point. Now, this point lies right on the line. We're going to include it too, right? Okay. So just make a similar picture for all the points that lie directly across from or on the curve. See if anybody's getting this. Okay. Again, marking points on this line. Okay, I'm going to shade part of this line that corresponds to this curve. Okay, but let's just take this point on the line. Does this lie across from a point on the curve? Where's the point on the curve? Well, it lies across from this point, doesn't it? So I could draw a line through here and it hits the curve. Okay, maybe that's another way of saying it. Okay, can I draw a line this point and hit the curve? When I hit the curve? Yeah, if I draw the line, let's just draw the whole darn thing. Just make sure we hit the curve. There it is. Goes infinitely far in that direction, Really, we're only interested in what's inside the rectangle right now. So I didn't need to go outside the rectangle still. Okay, this point would be part of what you shade, isn't it? Okay. What about this point? Does the horizontal line through that point hit the curve? Some are saying yes, some are saying no, but if I draw a horizontal line through this point, it doesn't hit the curve within this rectangle. Now, if I continued the curve on, it would continue getting lower and lower, and eventually it would hit that line, right? Actually, probably hit it before you get here. Okay. But as far as what's inside the rectangle, that point would not be shaded. Now, can you draw a line segment that would look something like this? That includes all the points that you would include. All the points that lie across from the point on the curve. Okay, I'm gonna have to ponder why you're finding this difficult, but most people are. And it's not that you aren't really good at following instructions, okay? You did things perfectly. And he came up with an outstanding result on the quiz, okay? So. Let's see if we make it clear. I'm gonna say that every point from this dot and this dot corresponds to the point of the curve. That makes sense? And that no other point, no point outside of this interval lies on the curve. Okay? Well, I'm just going to draw a note, and it's not one we're going to construct, but we want to get this down because it's one of the essential things you need to understand. Okay, so I'm going to draw through here. Starts here and ends here. And we'll put a red dot here so we can use on the red star. Okay, so show me a picture like this one that includes all the points on this vertical line, okay, that correspond to points on the curve. By correspond, I mean they lie on a horizontal line to the point on the curve. Yeah. Slot something down, looks like that. Doesn't have to be exact. It has any basic characteristics. That's close enough. It doesn't have to be that big, but a big one is always good. Okay, now you went from the upper corner to the lower corner, and I definitely started a little above the upper corner, ended up a little above the lower corner. You do want to do things like that. Notice that my graph doesn't go to the upper corner and it doesn't hit the lower corner, right? That's a main essential thing on the graph. Now, what part of just tell me. I'm going to start up here. This point, lie on a horizontal line, hits the curve. So that wouldn't be part of what you shade, this would. Okay. And we are recording. So, yeah. What about this point? Right. About this point. If I draw a horizontal line through this point, will it hit the curve? What about this point? What about this point? Okay. So can you shade the part of this line here, this vertical line? It includes the points for which you'd say yes. Okay, I kind of wish I'd have recorded this when I first did it, but again, I just did this. You know, here's a horizontal line through the top point, the highest point. Here's a horizontal line through the lowest point. Any horizontal line between there and there, and I could just draw something that represents like the almost infinite set of horizontal lines, although kind of wiping out my graphs, I should have done it a little bit later. And I want everybody to see it. Okay. So right there is a set of points. So the interval you would mark would be from here to here. That makes sense. And then another variation on that. it gets around the problem of wiping out parts of my curve, but not completely. Okay, so like this. And you say that you still have everything. From here to here, it did hurt. Actually hurt a little bit. So I want a little sympathy, okay? Okay, well. Not as bad as when I was working on my deck last night. Kept bumping my head into things on my scaffolding. And my neck is screwed up. Can't turn it more than about that. And that's more than I've been able to turn it recently. That's okay. So, you know, I finally got enough deck that I could remove those boards. But I was very, you know, didn't want the deck to collapse. So I was very careful about which boards I removed. So, and I went to see the doctor yesterday. Did a routine checkup. I mentioned the neck. He checked it out. And it's getting better. So I'm probably not going to go see anybody about it for right now, but he's giving me a referral in case I need to. Either. Then went home. The first thing I did is I went out on the deck. No boards to run into when I'm walking around. Well, the deck is about 8 feet high in places, so there's a place, I've got beams supporting my old deck. And then I cut the ends of the joists and put a new beam across there, about 46 feet. Okay, those beams are in place and they're great. And I need to do something with that new beam, which is higher than the old beam. So I climbed up on something and immediately ran my head into the old beam. Yeah, can't make stuff like that up. It's crazy. Now, I'm not sure what that has to do with this, but it had something to do with it a minute ago. Okay. What was the connection? There was a connection. But I'm not going to worry about it. Get the idea. Can you start seeing it?
Yeah.
Hey, what would you get for this one? Just to see if you're getting the idea. And it'll have red dot here, and we leave it on the line through the red dot. Just a quick sketch, something that kind of looks like a couple of little squiggles. See what you get. So the corners, I should pause for a second. Okay, so yeah, let me just. Okay, so again, the highest point is there, lowest point is here. The highest point on this side goes through here, also goes through the other part of the curve. So now I know that I can do this over here. I just did the ones on this half, the ones on this half. We said there's a little overlap there, but that overlap doesn't hurt a thing. Now we could also do, see if I can find the color that shows up a little better. Yellow and green is not a good combination. We could have done the same thing with vertical lines, okay? There's a vertical line goes here, and there's a vertical line that goes here, so that all the points in here are below. Okay, that makes sense. Same thing, only we're looking for in here, everything from here to here. Of course, I mark this. Okay, there's a name to this. Call this the domain. We call this the range. Now, we're going to put some numbers on the graph. We're going to have an x-axis. And a y-axis. Okay. Coordinates of this point are -2, 0. The x coordinates -2, the y coordinate is 0. This point has coordinates 2 and 4. The x coordinate is 2, the y coordinate is 4. That makes sense? We'll see. Okay. So, can you tell me what are the coordinates of this point here? What's the x coordinate and what's the y coordinate? Put a couple of parentheses here with a comma. Put the x coordinate here and the y coordinate here, x, y. Then an arrow here to the point. Just want to kind of assess whether you understand coordinates. If everybody does, then we can move on to something else. Otherwise, I'll do a little more explanation. Okay. Yeah, there was pause for now. I really explain that. Okay. Again, let's record it. But y equals 4 on this line. Because the point 2, 4 is on this line, and 4 is a y coordinate. It's a horizontal line, so every point has a y coordinate of 4. We cross the y-axis for y equals 4. Every other point on the line has some x coordinate and a y coordinate equal 4. This line here, horizontal line through the red dot, is the x-axis. And on the x-axis, y is always 0. Okay, now these things you know, but didn't necessarily use, so we want to make sure we make it very explicit. Okay, so y is 0 down here. Okay, so what I ask is I drew the vertical line here and ask which coordinate is equal to what. So label that up here so I can see it real quickly. And if you don't have it, just keep the question marks up. No, B. Now that wasn't Zoom's fault. That's something about the trackpad. Okay. Or my use of the trackpad. Okay, that's it. Here we got a horizontal line, the dotted line. Okay. On this dotted line, now we have the point 2, 4. And that means that y is equal to 4 everywhere on this line because the y value stays the same on any horizontal line. So y would be 4 here, y would be 4 here, y would be 4 here, and so forth. Down here on the x-axis, y is always 0. Because every point on this line goes over and hits the y-axis. It's the origin, where it's 0, where the red dot is, right? Okay. So now I drew a vertical line here. So let everybody draw the vertical line, okay? If some people didn't hear me because they're thinking about something else, I have done the same thing. No shame in that. So draw that vertical line if you have it. Equal sign, question mark, and then if you know what's there, erase the question marks. What goes here? What is it? X or Y that goes here? What number goes here? Okay, so again. X equals something on this line. And the hint is, well, everybody told me that, most of the class told me X equals 2. Everybody who voted held up 2 fingers, right? Because the X coordinate here is 2, the X coordinate directly below here is 2. Once we see this, then people quickly see that X equals 1 here. But why? Because, well, this is a y-axis where X equals 0, right? X equals 0 everywhere on here because every point here is directly above the red dot, which is the 0, the origin, 0 point on the x-axis as well as the y-axis. So halfway between here and here, and you know this is halfway between, you know how to construct this. Okay, so I'll try to build on your very good ability to do these constructions. But we want to put some symbols on it and some numbers. So X equals 1 here. Okay. And then we very quickly see that, well, then here X is going to be -2 because I gave you the coordinates at this point. Okay. And X equals -1 here. So that your answer up here is same as your answer, same as what we see down there. It's the same line, it's X equals -1. Everywhere in this line, the point on the x-axis directly above or below is -1. Okay. Just really try to get oriented to graphs. For many of you, the most important thing you carry out of this course is a good ability to see graphs and to see what they're telling you. Of course, you also have to be able to construct and what we're getting on that. Matter of fact, you already constructed this one, you just didn't have numbers on it. Okay. So now what I want you to do, I want you to make a table. I assume everybody's seen a table of y versus x. Okay. What I want you to put on that table is in the first column, the x coordinate of every one of these points. And then corresponding to each x coordinate, unless you put the y coordinate. Okay. So just tell me what the coordinates of each point are. You know how tables work. So try to refresh that, and maybe a little while since you did this sort of thing. Okay. So let's see how we do with this. Okay, what I've written down, 0, 1, 2, 3, 4 isn't right. But it's the most common thing that I'm seeing. And there are other errors, and most people have at least one error in these points. Now, if the error is in the fraction, well, we'll take care of that in a minute. Okay. But let's get the whole numbers and let's make sure we understand how we constructed this. Where is this line? It's halfway between here and here. You know that because everybody constructed the grid correctly, quickly, on the quiz at the very beginning of class without any reference, okay? So everybody knows that about this grid. So let's apply it. What's halfway between here and here? What's the number? Yeah. Y is the same everywhere on here. They don't say anything that we're recording, but y equals something. What is y equal? Give you a minute to ponder it, and then I'm going to ask you to hold up fingers. You ready? How many fingers? Okay, now most people hold up fingers are telling me 2. Seen a couple of 3s out there, but it's already 3. Okay, why not? Because what's halfway between 4 and 0? Is 3 halfway between 4 and 0? No, this line is halfway between the y equals 4 and the y equals 0 line. So this is the y equals 2 line. Okay. So what's this? This line, y equals what? Go ahead, hold fingers. Yeah. It's halfway between what and what? Halfway between what and what? Hold up fingers. this line and this line. On this line, y equals what? So we just said it equals 2, right? On this line, y equals 0. Okay, what's halfway between 2 and 0? 1. Okay. So we see that this is a line y equals 1. Now I'm going to leave it to you to ponder what this one is and this one. But you see that these lines are not equally spaced, and you know that perfectly well. Okay, you know that in the depths of your soul because you know how to draw this picture. And you do that very well. Okay, let's correspond the numbers to the picture. And they are 0, 1, 2, 3, 4. Because the lines are not equally spaced, right? Okay. Give you another minute or two. Okay. I've already labeled the y equals 2 and y equals 1 lines, and you should understand why y is 2 on this line. Because when you drew this line, it was halfway between here and here. And here's 4 and here's 0, right? Now this one is halfway between 2 and 0. Okay. What's halfway between 2 and 0? It's 1. That's why it's 1. So we'll worry about this one and this one in a minute. We'll put labels on it, but you want those labels. You want to draw everything that I've got on this graph. I'm going to ask you to do that as quiz next time, okay? Might ask you a few more things about the quiz. Because I want you to be oriented to scale of graphs. Now, I observe that what's happening in prerequisite courses is people never have to construct a graph. They're given a grid and then they put points on it and think they've constructed a graph. They haven't even constructed the grid. Or when they make a grid, it has nothing to do with the scale you need to use on the graph because they're always given a grid. Okay. And open math is always going to give you a blank grid because they don't really have a choice. Okay. We want to be able to construct these so we know what we're doing and we know what we're looking at. Okay. So we really have to work through this. All right. Well, the table, it's pretty clear that this point is on the y equals 4 line and it's on the x equals 2 line. Okay. Which means you're going to put 2 here and you're going to put 4 here. X equals 2, y equals 4. Right there it is. X equals 2, y equals 4. That's it. If it isn't, go back and watch me do these things again because you're not going to see it done this way in open math. Open math, I'm going to give you a grid and tell you to use a calculator, and that's no way to understand graphs. Sometimes you need to, but you don't need to for this graph. Now, if you want to figure out what the points are, at x equals 1/2, you're going to have to figure that out. Okay. But on the grid points, you do. And we'll worry about that later. Okay. This point, x equals 1 and y equals 2. So you have 1, 2. This point, x equals 0 and y equals 1. Okay. Now, most of you figured out and have it correct. Halfway between y equals 1 and y equals 0 is y equals what? Well, halfway is a kind of a hint. It's 1/2. Now, halfway between 1/2 and 0, here's where people often didn't know, but a lot of people did too. Okay. So about half and half. So halfway between 1/2 and 1. Think of $1. You cut the dollar in half, you got half a dollar, right? If you cut half a dollar in half, what do you have? You have 1/4 of a dollar, quarter. You ever seen coins before? I rarely use them. I keep some in here for physics because you do some really interesting things in propping up a ramp with coins. It gets into combinatorics and you're not going to make that for the distance. Okay. But it's 1/4. And if, again, that's really pretty basic in the fact that a bunch of pretty well prepared, smart people don't know that halfway between 0 and 1/2 is 1/4, apparently. And then the indictment of our education system, where they put calculators in your hands before you ever understand fractions. Okay? So you're gonna have to correct that. You're gonna have to understand fractions. But you don't have to understand everything about fractions right now. We'll develop it. Okay? And you'll understand that. So what you get is 1/2 and 1/4. Now, some of you wanted to use decimals. Okay. If you can do the exact fraction, I prefer to see the exact fraction because you have to understand fraction. If you use 0.5 here, 0.25 here, that's okay. But it won't be next time. Okay. But you should know, of course, that's 0.5 and that's 0.25. If I want to estimate the y coordinate of what color have I used here? Where are all my colors? Oh, yeah. If I want to estimate the y coordinate of this point, okay, then you're probably going to estimate a decimal. I'm going to say, well, the y coordinate, let's see, y equals what? The way I've got it drawn, at least over here, it looks like it's about halfway between here and here, so you might say 1.5, right? But over here, it's a little lower, and my line got a little bit high here. It's actually 1.4 to the nearest 10th. Okay. 1.414, if you want to go up to the thousands, that number just keeps going with no repeating pattern or anything. Okay. It's an irrational number. You can't ever calculate it exactly. You can't ever write it down exactly. Okay. So I'm not going to ask you to compute it. That's one you could use a calculator for if you knew what the formula was for this function. Okay. Very simple formula, but I'm not going to tell you today. Okay. So I'm gonna base what I see today, which is essentially that you all now know twice as much about graphs as you did when you came in, even if you're having trouble. Okay. And when you're done nailing this, you'll be well oriented to deal with these graphs. Okay. So I'm going to ask you, I'm going to give you some questions for homework. And if you have trouble with the questions, email me. Okay. I'm not going to be able to get them to you for a little while because I got to think what to ask, because I'm basing what I ask you to do on what I see you do. Okay. There's another graph I'm going to ask you to construct, and I'm just going to tell you, give you the instructions. Your grid is very, very close to this one. Okay, except there are a couple more lines. I'll even tell you, you're going to have a line halfway between here and here, halfway between here and here, and halfway between the lowest line and the lowest boundary. That's all. You'll have the grid, and the instruction is released. In instruction, I'll tell you, we're out of time, but start in the upper left-hand corner, move over 1, down 2, over 1, down 2, until you hit the red dot, and then you start moving over 1, up 2. Okay, you get a beautiful parabola. All right, just something to look forward to. You got to have something to live for. Okay,